Happy snow day, everybody. Okay, I'm just gonna jump right in to finishing this up. So we talked about how the determinant um, was based on all these different things, and I just want to back up just a tiny bit. But when we simplify, this becomes a positive one, this becomes a positive one. We need to find the determinant of this, which would be -2 times -2 minus -4 times by 1 plus this one stays as a -1 times our entry times by the determinant here. So we do that. This one becomes a +1, a -5, and then it's going to be 3 times -4 minus -1 times by -2. Sorry, I'm getting really squished here. I'm going to slide everything over. So here's all of this. Go ahead and slide this over so we can actually work with it a little bit more here. All right, so this will be 3 times a -4 minus a -1 times a -2. Okay, so now we just have to go ahead and actually simplify all of this. So,
oh, you're working.
Yeah, baby, I'm working. So this is -2 times -2 is +4, and then it's going to be minus -4 times 1 is -4. So this is really 4 plus 4, which is 8. So this whole section right here is going to simplify down to 8. I'm actually going to write it up here. And then in here we have 3 times -2 is -6 minus -1 times 1 is -1, which is really +1. So we're going to have a -1 times 1 times a -5, which gives us a +5. And then over here, we're going to have 3 times -4 is -12, minus -1 times -2 is a +2. So -12 minus 2, which is -14. And then we got to do -14 times by -5 times by 1. So we'll go ahead and do that. Let me get a calculator up here for you guys.
Mommy, I bet.
I know, sweetie. Give me just a second. So -5 times by -14 is 70. So we do plus 70. And that comes out to be 83. So what we're saying with this is that the determinant of matrix A is 83. This is the determinant. Okay. All right. So find the determinant using a method of your choice. Personally, I really like the diagonal method. I think it's a lot easier. So we're going to go ahead. Oh, that's as far as we need to go. And then we can do our diagonals. And our diagonals here. Okay, so these are all of our down diagonals. So when we multiply those, it's I times 3 times -1, which is a -3i. This one would be j times 1 times 0, which is just 0. This one would be k times 1 times -2, which is a -2k. Okay, and remember, we add the down diagonals and subtract the up diagonals. So these were our down diagonals, so these are all going to get added. Okay, so we would do -3i plus 0 plus a -2k. And then we need to do the other direction. Okay, so we need to do those three. We need to do those three. And then we need to do these three. But those three are going to get subtracted. So here we've got k times 3 times 0 is just 0. I times 1 times negative 2 is a negative 2i. And then j times 1 times negative 1 is just a negative j. And these ones we're going to subtract. So we're going to do minus 0 minus a negative 2i minus a negative j. So then we can come in here and fix some signs here. So the zeros are going to go away. This becomes a plus, this becomes a plus. So we end up with negative 3i plus 2i minus 2k plus j. And I like to go in alphabetical order here. We're going to combine these. So this is negative I plus j minus 2k. That's your determinant. And because this one had a row of variables, we can't go any further. That's it. That's all we got. So I'm going to go ahead and stop this video, and I will make another separate one for Kramer's rule. Please let me know if you have any questions, though.